Namaste and welcome back to the DSA classes. My friends, today we are going to be discussing a very famous interview questions, especially in your product-based companies such as Google, Microsoft, Amazon, VMware, Goldman Sachs. Are you interested to know what the question is? It is to find the median of two sorted arrays, right? And the beauty here is they're asking us to solve this question with a time complexity of big O of log of m plus n, and this is why it is asked in these companies. Now you must be wondering, what is this question and is it really that hard that all these companies are asking this? Let me give you an idea of what the question is actually expecting us to do. Okay. Now first of all, I would like to explain what do you mean by a median inference. What is a median, right? Try to understand this. So first of all, case number 1, assume there are odd number of elements in my array. Okay, so let us assume this is an array. Okay, so 0 to 8 means there are totally 9 elements, which is an odd number. Let us assume these are the elements inside the array. Now what is the median, if you ask me? The median has a formula which I am showing. Median is equal to the total number of elements divided by 2. If in case there are odd number of elements, and total number of elements is 9. 9 divided by 2 is nothing but 4, which means at the 4th position you have your median. And which is the value at the 4th position? 7. So 7 is your median. Any confusion till here? And why it's called as the median is, if you look at it, it kind of divides your array into two equal halves. See, there are 4 elements on this side, 4 elements on this side. That's why median. It's sort of like a middle value. Any confusion? Great. But what if you have even number of elements? Naturally, that's the question you will have. So that is my case number 2, where I have even number of elements, and let us assume this is my array. Now 0 to 9 means I have 10 elements, which is even. These are the elements. Now the median formula changes, okay? Because if I try to find the middle value, 10, total number of elements is 10. 10 divided by 2 is 5. 5 cannot be the median, because look at 5. This side of 5 there are 4 elements. This side of 5 there are 5 elements. So clearly it's not dividing the numbers into two equal halves. It's not doing that. So in such a case, what they ask you to do is, they ask you to find the average of these two numbers, 4 and 5, the element at the 4th position, element at the 5th position, 7 and 8, their average is your median. Any confusion? So here also, you take the total number of elements divided by 2, you will get 5. Now the element, the mid element, and the mid minus 1 element, these two elements you take them, add them together. 7 plus 8 is 7 plus 8 divided by 2 is nothing but 14.5. so in this case your median is 14.5. Any confusion till here? So naturally, as a programmer who is going to write logic for this question, you have to consider both these cases. Okay, now let's come to the expectation of the question. Listen to me and listen to me carefully. Now what they are basically telling you is, they will give you two arrays, my friends. This is array number 1, this is array number 2. If you look at these two arrays, what immediately catches one's attention is that this is also sorted. This is also sorted. Now you are supposed to find the median of two sorted arrays, 1, 3, 8, 17, sorted in the ascending order, 5, 6, 7, 19, 21, 25, sorted in the ascending order. Both are sorted. Now you must find the median of these two sorted arrays. Now how will you do that? Naturally, if you have to find the median of two sorted arrays, you must combine them together or merge them and make them into one single array. Only then you can find the median, right? Common sense. Which means, first and foremost, what we have to do is merge them. Okay. Now, obviously, if you are going to merge them, you will need a new array. And what should be the size of that new array? The size of the new array should be such that it will be able to accommodate all the elements in the first array and all the elements in the second array as well. Any confusion till here? So how are you going to do that? So very simple. I have a total of 4 elements here. I have a total of 6 elements here. So 6 plus 4 is 10 elements, and hence I am going to create a brand new array whose size is 10. I am going to create a brand new array whose size is 10. Any confusion till here? Size of the array is 10. Good. Now, one by one, I should add elements here. Now, how should you add it? Now, think about it. This is sorted, this is also sorted. Naturally, the merged array also should be sorted, right? The merged array also has to be sorted, which means how are you going to merge two arrays such that it is sorted? Very simple. Listen to me. What I will do is, I am going to create a pointer I or an index or a looping variable I for the first array. I am going to create a looping variable j for the second array. I am going to create a looping variable k for the merged array, which I am calling as n. Okay. Now see, what I will do is very simple. Now at this position, either I should store the element at the ith position or I should store the element at the jth position. Would you agree this is what I should do? Now my question is, if this array should be sorted, which among these two elements will you be putting? Will you be putting the lesser element or the greater element? Obviously the lesser element. That is your condition. So see what I will do. I will check if in case the element at the ith position in array 1, if it is lesser than the element at the jth position in array 2, then if it is lesser, what I must do is take that ith element and put it at this kth position. Would you agree? That is what I am doing. See, AR1 of I, assign it to M of k. So you assigned it. So 1 came and sat here. Next what? Next what you should do is, obviously, think about it. Should I move forward or should j move forward? If you have common sense, you will tell me, I we have already stored, sir. Obviously, I should move. Jth element has not yet been stored. So j should be wherever it is. So see, I will move I forward. Now, not only should you move I forward, I plus plus I will tell, but would you agree, kth position you have already stored an element, which means next element should come at the next position. So would you agree, k also should be moved, k also should be moved, k plus plus. Any confusion? Simple condition. Similarly, next, okay, if in case the ith element was not lesser than the jth element, then this is what you had to store. So see, if this condition is not true, else, otherwise what? Otherwise, take the jth element, store it in the kth position. That's what I am telling. AR2 of j, store it in M of k. Obviously, after that, j should move forward, k should move forward. That's what I am telling. J plus plus, k plus plus. Any confusion till here? Now, let us trace the program and check. Okay. So basically, I was here and k was here. The next time I will again check. So I'll take 3, I'll compare it with 5. Obviously 3 is lesser, which means 3 has to be stored here. So I will store 3 here, and then naturally I am going to increment I am going to increment k. Again I will check, is 8 lesser than 5? If I check is 8 lesser than 5, no, 5 is lesser than 8, which means jth element should be stored at the kth position. So see, 5 gets stored here, 5 gets stored here. After which, what should you do? Increment j, increment k. That is what I am. Increment j and increment k. Again see, is 8 less than 6? No, 6 is less than 8, which means what has to be stored is 6. So I am storing 6 at the kth position. After which, j has to be increased, k has to be increased. Again compare ith element with jth element. 8 with 7. Is 8 lesser than 7? No, 7 is lesser than 8, which means take 7, store it at the kth position. After which, increment j, increment k. Any confusion till here? Again continue. Is 8 less than 19? Yes, ith element is lesser than jth element. If this condition is true, then ith element store it at the kth position. So 8 gets stored at 5. After which, you have to increment I, increment k. Again compare. Is 17 lesser than 19? Yes, which means store 17. Increment I, increment I. How are you able to see? I goes outside the index. Great. Increment k. Any confusion till here? Now tell me, one of the arrays you have traversed it completely. Now you should not do comparisons, because now what will happen is you will be trying to access elements which is outside the boundary of the array. You will get array index out of bounds exception if next time you try to do this comparison. Which means, would you agree that if in case either I goes outside the boundary or j goes outside the boundary, of their respective arrays, you should immediately come out of the loop. That is your termination condition. But if I say, sir, it is not yet completely merged, sir, there are more elements. I will come to that, don't worry. I know these elements are still to be put. But what is my exit condition is if in case I come, if in case one of the values, either I or j goes outside the boundary. So how will I check that? I will tell, hey, please continue to do these operations as long as means what? While. As long as what? Either I is still within the boundary of the array. How will you write that condition? I less than length of array 1. Length of array 1 will give you the number of elements. How many elements are there? 4. If the index you are at is less than 4, it means you are inside. 0 is less than 4, 1 is less than 4, 2 is less than 4, 3 is less than 4. So I less than length of array 1. And I should also be sure that j is also inside its array. So how will you do that? J is less than length of array 2. Length is 6 elements are there. Valid index is from 0 to 5. So all these indexes are less than 6. But if it becomes greater, come out. Would all of you agree this is my condition? Okay, I will come out. Now once I come out, two things may happen. One is, I may not have added all the elements in my first array into my merged array, or I would have not added all the elements in my second array to my merged array. In this case, clearly you can notice these three elements which is left out in my merged array I have not yet added. So to do that, what should you do? What you do is come outside and check if in case either of these indexes, either of these values I or j, is it still within the boundary of the array? If it is still within the boundary of the array, there could be more elements as it is added. How will you write that? Simple. I'll write a condition. As long as I is less than the length of array 1. If I is less than the length of array 1, more elements were left out. If more elements were left out, simple. See, this is the logic to take elements from the first array and store it inside this merged array. Take this, put it here. Same thing. I'll come out of this loop. One more loop I will write where I will check. Hey, please check if j is still inside the boundary of the array. What is the condition? As long as j is less than the length of array 2. It means j is still inside. If j is still inside, take the remaining elements and put it here. And what is the logic to copy element from j and put it inside m? This is the logic. Copy that, put it here. Simple. That way you would have taken care of it. Now watch it. If I check if I is inside the boundary of the array, I'll get false. This loop will not execute. I'll come outside because see I is outside. I'll come here and check, is j inside the array? If j, then whatever is remaining, take it and put it. That is what I'm saying here. And if I do that, 19 comes, 21 comes, 25 comes. So look at n. Have you got the merged version of array 1 and array 2, and is it also sorted? Definitely it is. Once you do this, then all that is remaining for you is to find the median. How will you find the median? Very, very easy. To find the median, all you have to do is check what is the length of this merged array. If the length of this merged array happens to be even, then apply even formula. If it is odd, apply odd formula, and that I already taught you here. Hope you are able to think. So the point is, how are you going to merge them? After that, median is just one line. But now listen to me. The core operation here, or the operation which is going to take most amount of time by your CPU to perform, is nothing but merging. Shall we analyze what is the time complexity of this? Very simple. Ultimately, you have to iterate over the entire array. Let us assume this array's length is m. You have to iterate over this entire array's length. Let us assume this array's length is n, which means complete m you have to go through, complete n you have to go through. Which means, would all of you agree, I can say the time complexity is big O of m, because I am going through the entire m array, plus I am going through the entire n array. So big O of m plus n. Big O of m plus n. Now What did they want from you? They wanted big O of log of m plus n. What have you got? What have they asked? Clearly there is a mismatch. Definitely it is not log. So clearly this is an inefficient solution. And if the solution was so easy, you think Google will give you an offer letter? You think Microsoft will take you in? You think Goldman Sachs will take you in? Clearly they are expecting something totally different. And that is why this is one of the most favorite questions asked in the interview. How to optimize it? In the part 2 of this video I will explain. But first, shall we go code this and check if it works? Let's do that. Alright, so let's start. As you can see, I've created a function called as find median. It accepts two arrays and basically we have to first merge them and find the median. Okay, so let's do the merging first. So I'll just create three variables, int I equal to 0 and j equal to 0 and k equal to 0. Okay, next I'm going to create a new array which the size is the size of array 1 plus array 2. So new int, and basically size is going to be ar1 dot length plus ar2 dot length. This I'll give it a reference, I'll call it as m. This is my merged array and obviously it's an array of integers. Okay, great. Assignment, yeah. Now I'll come down and I will write my while loop for merging. So as long as I is inside the boundary of array 1, so I less than ar1 dot length, and j is inside the boundary of array 2, so j less than ar2 dot length. If this is the case, then what I will do is I'll check if in case the ith element in array 1 is less than the jth element in array 2. If this is the case, then I know the element in array 1 should be stored inside m. So I'll tell m of k is equal to ar1 of I, and then I'll increment I pointer, I'll increment k pointer. Else means that j was lesser than I. So what I will do is I'll just copy this code, paste it, and all I will do is that ar1 I'll make it as 2, I will make it as j. Instead of I plus plus, I will tell j plus plus. That's it. Now I'll come out of the loop. If in case I come out of this loop, now maybe the sizes of the arrays are unequal. Maybe the smaller array went outside its boundary, so I came out. Now the larger array's elements are still pending. I should put it. I'll be able to think. So for that, I don't know which is the larger array. Could be I, could be j. So what I'll do is I'll check if while as long as I is still inside the boundary, I less than a dot length, ar1 dot length. If in case I is still inside the boundary of my array 1, it means more elements are there. So I should take and paste it. What is the logic? This is the logic. Copy that, paste it here. Right? Similarly, I'll come out of this. Now, if in case I went outside the boundary, I know I've covered all the elements. So this first time only condition will be false, I'll come outside. Again, I'll tell while j is less than ar2 dot length. In which case, what I will do is all the elements, pending elements in j, I should store it. So what I will do is this part I will just copy, paste it. That's about it. Great. Now, once I come out, here I would have found my merged sorted array. Now I have to find the median. Very simple. First of all, let's check whether the merged array size is even or odd. Okay. If it is even, then very simple, divide it by 2 and that is your median. If it is odd, then the mid value and the mid minus values average you have to find, or it's the reverse for even mid and mid minus 1, for odd mid value. I said the reverse, but I hope you understood. Okay, so I'll go here and I'll tell if in case I'll check m dot length, I will divide it by 2. So m dot length, I will mod 2. I will do mod 2 means I'm checking if it is perfectly divisible by 2. I'll check if it is equal to 0. If it's perfectly divisible, scroll on top. Then what I am going to now do is I will apply that formula. So what I will do is I will first find the mid value. Okay, so I will just tell low is equal to or you can just tell mid is equal to int mid is equal to 0 plus, or just a dot length by mid length by 2. Length by 2 you will get the mid. Okay. Now because I know it is even, so I am just showing you an even length array. That is the mid value. Now that mid value and mid minus 1 values average you should find and return. So that's what I am doing. So I will just tell m of mid plus m of mid minus 1. This I will put within parenthesis. This its average means divided by 2. Divided by 2. This is the average. Now it could be an integer, it could be a floating point value also. But we should not return integer, we should return float. So what we will do is we will just typecast this to float. Because it is integer by integer division. So now if in case you do like this, so you will get a floating point value. Any confusion? That is what I will store it, or that is what I will just return it directly. I will return. So this is my median. Any confusion till here? Else. Else means it was odd. Else means it was odd. Odd length means just directly you can tell int mid is equal to m dot length divided by 2. Mid is equal to m dot length divided by 2. And what I will do is I will just go and return the element at that position. So return m of mid. That's it. That's it. Now I will scroll on top and I will change the return type to float, because what we are returning is float. Any confusion, dear friends? Okay, cool. Now that you guys understood this, if I scroll down to the main method, you can notice I have created 2 arrays and I have called find median, passed both my arrays. Let's quickly execute it and check. So if in case I execute it, then you have got 7.5, right? So it works because there are totally 4 elements here, 6 elements here, 6 plus 4 is 10. So 10 elements means it's the average of the 2 middle elements, and that comes up to be 7.5. Any confusion till here? So it works, and it works perfectly. However, as I told you, the time complexity is big O of log of m plus n. This, it is not log, I am sorry, big O of m plus n. Now it's linear time complexity. We have to make it logarithmic. Now, definitely with this logic, you can never make it log, but can you make it a little bit more efficient, if you ask me? Yes, you can. How to do it? Let me show you. Now, my friends, there is a small optimization that you can do in this existing code itself. Now, think about it, okay? Ultimately, you are merging these 2 arrays and creating the merged sorted array, right? But tell me, to find the median, you basically need this middle element. That is what you need. You need this middle element. Once you get the middle element, if it is odd number, directly you will return it. If it is even number, you will take these 2 numbers. So which means, tell me, if I am a programmer and I am merging 2 arrays, then after the mid, whatever elements are there, all these elements, is it of any use to me? They are of no use to me. So would you agree that if merging can happen till the midpoint, it is more than enough for me to calculate the median? More than enough for me to calculate the median, which means this half can be completely avoided. You can avoid it. So how will you write the condition? Very simple. You guys know it is this k value which tells you which position you are in. So k is 0, k is 1, k is 2, k is 3, k is 4, k is 5. When k comes to 5, you must stop. Now this 5 is the mid position because the size here is 10. But it could be anything, any mid position, right? But to get this mid position, would you agree, it's very simple. It is nothing but length of this array divided by 2. Length of this array is 10 divided by 2. So see, what I will do is, here I will write a condition. I will add another condition. So I will tell and I will add one more condition. I will tell, please do this only as long as k value is less than or equal to the length of m divided by 2. The moment k value becomes greater, I don't want to do any merging because it is pointless. It is pointless. Similarly, if I come outside this loop, please understand, I would have come outside the loop maybe because I condition was false or maybe j condition was false, not necessarily k. K would have not reached till here. Before that only I would have come out. For example, let us assume this array had only 2 elements. If this array had only 2 elements, then by the third iteration I value would have come out. So you would have come out of this, only 2 elements you would have stored here, and then k value would have not even reached till here, which means the remaining elements you should store. Now even the remaining elements that you store should only be up until k. So would you agree? Even in this loop, I should add and k less than equal to length of m divided by 2. Even in this loop, I should add and k value less than equal to length of m divided by 2. So if you do this, the advantage is that definitely halfway only you will be doing merging, which means your time complexity, which was big O of n plus n, will now become n plus n divided by 2. How are you able to think? But the sad part here is, you know, in time complexity analysis, constants don't matter. If constants don't matter, then this 2 is gone. Again, you are back to m plus n only. But definitely, you know, it is better, but still it is linear only in a way, not much difference. As the size of the arrays increases, linearly only it will increase. I hope you're able to think. So it is big O of m plus n itself. Now, I'm sure all of you are confident enough to go and make this small change in the program and test it out for yourself. However, let's catch up in the next part of this video where I'm going to show you a mind-blowing optimized solution for this particular problem. Okay? Thank you so much for tuning in. Catch you in the next class.